Okay, on this example, we're going to use the limit definition of derivative to find the slope of the tangent line to this curve, f of x equals 3x minus 5. And then we're going to, after we find that derivative, go ahead and evaluate it at x equals negative 7. So I'm choosing to plug in the negative 7 after we find the derivative with x's involved. So off to the right-hand side, I've gone ahead and listed the derivative here with the slope limit definition, where we have the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's get plugging in here and work this out. So we want the derivative is going to be the limit as h approaches 0. And then as we fill in, what we want to be aware of is initially we want to replace x with x plus h. All right, so this is going to replace the x on the left-hand side. It's also going to replace the x on the right-hand side. So hopefully not too bad. Instead of 3 times x minus 5, it's going to be 3 times the quantity x plus h minus 5. All right, then after that, we need to subtract the initial function. So we're going to do a subtraction, and then we're going to replace f of x with the right-hand side, what it's equal to. So again, bring along our subtraction, but then be careful. It's the entire original function that needs to be subtracted away. So I'm going to put a set of parentheses and then copy down the right-hand side, 3x minus 5. Where errors tend to occur is we forget to put that set of parentheses so that negative doesn't get distributed. All right, so our next step is going to be go ahead and do a little bit of simplifying down. Use our algebra skills and distribute our 3 to get rid of this set of parentheses. So a 3 gets distributed to each one of those terms. So 3 times x will be 3x. And then we have 3 times h is going to be 3h. Bring along our minus 5. And then do a little bit more distributing. As I mentioned, that negative, think negative 1 times each one of these terms. So what that does is switches the signs on each one of them. So negative 1 times positive 3x is negative 3x. And then negative 1 times negative 5 is going to be a positive 5. All right, at this point, we can go ahead and think about simplifying this down by combining like terms. You'll notice we have a positive 3x, and we subtract 3x also. So as we combine those together, we're going to end up with 0 x's. So that term basically, they're eliminated. We also have negative 5 and positive 5. So as we combine those together, simplify down, they'll be eliminated as well. Well, this simplifies quite a bit for our function. So let's think, what didn't get eliminated yet? Well, we have 3h and the h in the denominator. So to evaluate this limit, we'd like to plug in 0 for each one of our h's to kind of finish it up. But you'll notice if we did it right now, we'd have 0 over 0, which isn't very nice. So let's continue simplifying down. Now on this one, we have h multiplied by the entire numerator and h multiplied by the entire denominator. So h over h makes 1. So in this case, we end up with the limit as h approaches 0 of simply 3. Well, there are no h's left over, so if we think about plugging 0 in for our h, there aren't any h's, so we're just going to be left with 3. So our derivative, f prime of x, is simply going to equal 3. All right, well, let's use that. We haven't done anything with this evaluating it at x equals negative 7 to give us the instantaneous rate of change. So let's think about how that's going to look. So we need an x value equals negative 7. So our function, its derivative is going to be simply 3, which is a constant. So if we think about evaluating that at 7, double check, it was negative 7 actually. So if we put a negative 7 in, we're still going to get that same constant function. All right, it's still just going to equal 3, which kind of makes sense if we think about the slope of the tangent line. After all, if we have a line, our initial function, think about that, it was 3x minus 5. That's going to be a line with a y-intercept at negative 5 and a slope of 3, meaning no matter what point you pick on here, if we think about a tangent line to that curve, it's going to be the exact same as our initial line. All right, so it's going to have the exact same slope, meaning that since we're trying to find the slope of the tangent line to the curve, it's going to be the exact same as the slope of that line. All right, so the slope of our line, sure enough, is 3. That's the slope of the tangent line to this curve as well. All right, so now we've gone through all the steps for finding the derivative and then evaluating it at the given value. So I hope this helps out as you're thinking through working with the limit definition of derivative. Good luck, just take some practice.